Hello, Amira, welcome back.
Hello.
Amira, on your surface, do you write with a pen or with a mouse? How do you write on the screen?
I write with a pen.
Okay. So is it comfortable writing on the screen with your pen?
Yes.
Okay, good. And sometimes I may ask a question, it will show on the screen. Okay. So Amira, here we will learn one more thing that is related to coordinate geometry. It is area of rectilinear figures. That means a rectilinear means all sides are straight line. It's not like a curve. And also actually using if the vertices, I mean the coordinates of the vertices of that figure is given, and also we can find it is area without actually drawing that figure. That's also interesting thing. When it's just say rectilinear, these are some examples for rectilinear figures. As you see here, all sides are, what is this, straight line? Also, and actually also call them polygons, right? Here we have pentagon, rectangle, square, triangle, this thing. Okay, with this rectangle, we can find this area simpler, right? Because just length times width, we can find this area. And also if it is a square, it's fine. But it is something like this, for example, let's say this pentagon or hexagon or something weird, okay? So how do you find this? Still we can find this, but if we know the vertices of this figure and just using one formula, we can find it is area. So in this parts, I'll just give you some idea about this. Actually, that is a formula. You don't have to, actually you can memorize, and memorizing not so difficult, but here I'm just going to show you or prove it why actually this formula works. Okay, and also just to give you some idea, because in math, when you're learning definitions, of course, they don't require proof, but theorems, okay. But if you learn theorems with proofs, not every theorem, but most theorems, actually, it gives you some kind of not only problem solving, looking at things from different point, from different angle. This is how what we learn from learning the proofs of theorem. I mean, in this regard, I'm going to prove actually everything that we are going to learn in this class. Okay, that really helps you a lot, even when you take any math related course at the university. So that is a formula. If you're given any rectilinear figure, okay, maybe it's triangle or quadrilateral or pentagon, hexagon, heptagon, octagon, whatever it is, n-sided figure. We are just using this formula, the area of the polygon with vertices A, B, C, blah, blah, blah. And so writing at the top, x coordinates, x sub 1, x sub 2, x sub 3, x sub 4. And here we have y coordinates, y sub 1, y sub 2, y sub 3, y sub 4. Actually, in math, we call this determinants, but we don't have to know the name right now. Okay, we are just in compact way how we calculate this. How do you evaluate this? Here we have 1 over 2 times sum of all products and slope down in this direction. That means that here we have x1, y2, x2, y3, x3, y4. That sum of all products. This arrowhead means we mean this thing. And here we have x sub n, and the last one is the first point. Minus sum of all products, this direction. That means it is here and here and here. This is how you should understand actually this formula. Just for simplicity, let me just give you one example. Let's say we are given some kind of triangle. Now we are going to prove this thing. There's a triangle. Let's say this one is A. Make sure that it is anti-clockwise direction. Even anti-clockwise direction doesn't matter, but the sign will be negative. So here we have, let's say B, and here we have C. And coordinates of A, let's say X sub 1 and Y sub 1. And this one is X sub 2, Y sub 2. And this one is X sub 3, Y sub 3. The question is, if you know the coordinates of the vertices of this triangle, how do you calculate using this formula? So the area of this triangle ABC is saying that just write it as 1/2. And here we have vertical line here. Just write here the coordinates starting with x sub 1. And here we have x sub 2. And here we have x sub 3. And the first coordinate. And here we have y sub 1, y sub 2, y sub 3. And here we have y sub 1. And how do we evaluate this? That's just equal to 1/2 times. Here we have x1 times y2, x1 times y2, plus x2 times y3, x2 times y3, x3 times y1, x3 times y1, minus, now in this direction, x2 times y1, x2 times y1, plus x3 times y2. Here we have x3 times y2 plus x1 times y3. x1 times y3. So this thing actually gives us the area of this triangle. And why is it so? Why is it so? Now we'll try to answer this question by answering the first, by doing the first example. So area of plane figures. It says here, find the area of the triangle with vertices a x sub 1, y sub 1, a x sub 2, y sub 2, a x sub 3, y sub 3. That means that we need to draw or generate a formula for this. So what is this? Assume that we are given this triangle something like this. Okay, let's say our triangle is something like that. And let's say this point is A, and this point is B, and this point is C. And this one is our x-axis, and this one is y-axis. So coordinates of A, that is x sub 1, y sub 1. Let me just use red here for that. So this thing is, okay, x sub 1. And here we have, this one is y sub 1. Coordinates of B, that is x sub 2 and y sub 2. And how about C, that is x sub 3, and this one is y coordinate is y sub 3. Okay, the idea is interesting to find the area of this ABC. So we need to find the area of this shaded region. Okay, so let me just write here. What is the area of triangle ABC? Before doing this, we know that what is the area of trapezium, Amira?
The area of the trapezium, like the formula.
Yeah, just tell me, what is it? How do you find the area of a trapezium?
It's the base, isn't it the two opposite sides divided by 2, and then you times that by the height?
Yeah, that's right. The sum of the parallel sides, right, over 2 times height. Good.
Yeah.
I'm going to use this idea to find this area. If you just look at this, the first one is, let me use maybe green to find this triangle. All right. I'm going to use this trapezium. If you look at this green part, or from here, this here. Let me just this so that you don't get confused. Let's say this one is ABC. Let me just use this one as D, and this point is as E, and this point as F. Okay, so can you see this trapezium ADFC? ADFC. Okay, if this is a trapezium, right? What is a trapezium? It's a quadrilateral or special quadrilateral with a pair of parallel sides. So this sides are parallel, that's vertical. This side is, and this side is parallel. And since actually these are 90 degrees, that means that this DF is its height, right? So, okay, with the from the area of this trapezium ADFC, that gives us this trapezium's area. minus the area of this smaller trapezium A, D, E, B, minus the area of the trapezium B, E, F, C. It gives us the area of this triangle, right? So I'm just going to write this area of trapezium ADFC minus area of the other trapezium, that is ADEB. ADEB minus also, if I just remove this part, that is BEFC, area of BEFC, it gives us the area of triangle ABC. Now the only thing here is we have to evaluate this. When we evaluate this, actually we will get that formula. Now as you said, actually this one is trapezium, that is also trapezium, that's also trapezium, and the area of the trapezium is half the sum of the parallel sides times height. That means that every formula here, it contains half. So I'm just going to write that half outside. So that is equal to, let me just write here, 1/2 times the first one. What is the area of trapezium ADFC? ADFC is the sum of the parallel sides. And AD and FC, they are parallel to this side, right? What is the length of AD, Amira? What is the length of AD?
That's the
Y sub 1, right?
yeah. That's
And
just
see here, it's just the length of AD is Y sub 1. That is Y sub 1 plus, and what is the length of FC? That is Y sub 3 here. That is Y sub 3 times, we should be careful with this subscript notation, otherwise we'll get confused. Anyway, how about the height of this trapezium from DF? That is x sub 3 minus x sub 1, right? The distance between x1 and x3. That is x sub 3 minus x sub 1. That is the area of the first trapezium. Minus, let me just write minus here because we don't have enough space. How about ADEB? Now in a similar way, ADEB. AD is parallel to BE. The length of AD we know is equal to Y sub 1. So here we have Y sub 1 plus the second parallel side. The length is Y sub 2. Excuse me. All right. So the sum of the parallel sides and the height. What is the height? It is DE, the distance between x sub 1 and x sub 2. So that's equal to x sub 2 minus x sub 1. Minus, how about the area of the third trapezium? Here we have the small trapezium, and the sum of the parallel sides. This one is y sub 2, this one is y sub 3. So here we have y sub 2 plus y sub 3. And the height. What is the height? The distance between x sub 2 and x sub 3. That's equal to x sub 3 minus x sub 2. Okay. Actually, that is it, how we find this. Now, mathematicians, when they actually discovered this, when you just expand all of this stuff and write all the expressions whose actually the sign is plus, the first bracket, and whose signs are negative in the second bracket. And after that, they noticed that we can just write in the previous order, that formula in such order. Okay, and when they just check not only for triangle, for quadrilateral, for anything, that's why actually they just generalize to any polygon. Now we will see this. So equals, again, I will just give this one over to here. So here, I am going to expand this, but not in a just way, okay, but in such a way that first here, I'm going to write all the terms that their signs are positive. I can just put bracket here, maybe. And all the terms that their signs are negative here. Okay, actually, it is something like this, but I need more space, but this minus sign, I'm going to write here below. So if you expand this here, as you see here, if you multiply this thing by x sub 3, it will be positive, right? So what will we have here? y1 x sub 3. So here we have x sub 3 y1 plus x sub 3 y sub 3. X sub 3 y sub 3. This minus, I will write it here. Here we have minus, open bracket here. Here we have x1, y1. So here we have x1, y1, and minus x1, y3, plus x1, y3. Okay, that's the first one, done. How about the second one? If I multiply this negative x1 by these things, because of this minus, it will be plus. So here we have x1, y1, plus x1, y1, and x1 times y2, plus x1, y2. But if you multiply x2 by this, because of this minus, it will be minus. So I'll write it here. x2, y1, plus x2, and here we have y2. Okay, the last one, here we have, if you multiply this minus x sub 2 by this expression, because of this minus, it will be plus. So here we have plus x sub 2, y sub 2, plus x sub 2, y3. I can close the bracket now. Now, if you multiply x sub 3 by this, you'll get minus. So minus is already outside here. Here we have plus x sub 3, y sub 2, plus x sub 3, y sub 3. Okay, now I can close our rectangle bracket. Anyway, now if we can simplify this, see here, x sub 3, y sub 3, minus, here we have x sub 3, y sub 3, here. So they cancel each other. And x sub 2, y sub 2, minus, here we have x sub 2, y sub 2. Also they cancel each other. And here we have x sub 1, y1, minus, here we have x1, y1. Also they cancel each other. But other terms are all different. X sub 3, y1. Do we have here? No. How about x1, y2? Do we have here? No. x2, y3. Do we have here? No. Now, if you notice here, if I just write from here, let me just write this one in the first place, x sub 2, y3 in the second place, x sub 3, y sub in the first place. What happens here? It is, here we have still 1 over 2 times, actually we just get here, x1, y, x2, x3, x1. Here we have y1, y2, y3, y1. We can just write it like this. x1 times y2. Do we have it here? Yes, x1 times y2. And x2 times y3. This one is y3. x2 times, where is it? x2 times y3. It is here. x3 times y1. x3 times y1. Done. How about the second one? Because of this minus, so that's why we have minus. Here we have x2, y1. This one is x2 times y1. Here we have. And x3, y2. x3, y2. Here. And the last one is x1, y3. x1, y3. So that means that since actually if you just evaluate the value of any polygon, it will be some kind of this order. And they have just generalized that then any polygon's area can be found using this formula. We just need to write x coordinates at the top, y coordinates in the bottom, but make sure that it is anti-clockwise direction. Even if you just count this as clockwise direction, it doesn't matter. Only the result will be minus, and just ignore the minus. Still, it gives us the area of this polygon. Okay, and also memorize this so easy. x1, x2, x3, x1, y1, y2, y3, y1. If it is quadrilateral, it has 4 vertices, x1, x2, x3, x4, x1, y1, y2, y3, y4, y1. If it is pentagon, hexagon, just continues like this. Okay? Let's see one example immediately for this. Find the area of the triangle with vertices. Okay, locations are not important, just we need to know actually these are in clockwise or anti-clockwise. So here, that is our Cartesian plane, x-axis, and here we have y-axis, 1, 7. 1, 7, it is somewhere here. Let's say it is A. B, negative 2, negative 4. Negative 2, negative 4, it is somewhere here. This one is B. And the 2, negative 1. 2, negative 1, it is somewhere here. This is C. So this one is A and B and C. It is already in anti-clockwise direction, right? A, B, C. So now what is the area of this triangle then? The area of this triangle ABC equals 1 over 2. So at the top, we need to write x coordinates starting from A. That is 1, negative 2, 2. 1, negative 2, 2, and also the first coordinate here. And y coordinates, here we have 7, 7, and the second one is negative 4. Third one is negative 1, and it is 7. So here we have 7. So that gives us the area of this triangle. That is equal to 1 over 2. Let's open this, here is a positive. 1 times negative 4, that is negative 4. Negative 2 times negative 1 plus 2. 2 times 7 plus 14 minus negative 2 times 7, negative 14. 2 times negative 4, negative 8. 1 times negative 1, that is negative 1. Equals, that is 1 over 2. Negative 2, 4 plus 2, that is negative 2, plus 14, that is 12. And the minus minus, it is plus because all these are negative numbers. 14 plus 8, 22, plus 1, that is 23. So that's equal to 35. So the area is 35 over 2 units squared. Okay?
Mm-hmm.
Especially for computer scientists or programmers. For example, if you're dealing with this kind of stuff, actually, if you're given any polygon in the computer, just we need to know the vertices of the polygon. Then they can evaluate the area. That is one advantage of knowing this formula. Another one is here, you don't have to find the base. You don't have to find, what is it, the heights. And okay, a triangle also is not much difficult. How about if it is quadrilateral? It is really hard, not easy. You need to divide into two triangles and find each one's area. How about pentagon? How about hexagon? And this formula is very quick and very easy and very practical. That is really, really one important application of, or not application, big contribution of coordinate geometry to our modern mathematics or science. Anyway, let's continue. That is one example. How many examples we have? Okay, just 2 examples. That much is enough to give you some idea about this thing. Find the area of the polygon whose vertices are, let's say, negative 2, 6, 1, 5, 2, 1, 0, minus 1, minus 3, minus 1, and minus 4, 2. Okay, what are this? If you just plot these points in the Cartesian plane, so that is our y-axis, x-axis, negative 2, 6. Let's say this one is A, this one is B, this one is C, this one is D. I don't know actually this in this order or not. Later, if it is wrong, I can change this. Negative 2, 6, negative 2, 6. It is somewhere here. Let's say this one is A. And 1, 5, 1, 5 is somewhere here. It is B. And 2, 1, 2, 1 is somewhere here. That is C. 0 minus 1, 0 minus 1 is somewhere here, that is D. And minus 3 minus 1, minus 3 minus 1, it is somewhere here, that is E. And minus 4, 2, minus 4, 2, minus 4, 2, it is somewhere here. That is, what is it? F. Okay, so if you just join these points, we will have something like this. Okay, so we need to find the area of this shape. As you see here now, A, B, C, D, E, F, that is actually, what is it? Clockwise direction. That's why it will be, the answer will be negative. Since actually we're going to get the area, because I have already labeled, maybe I need to subform here maybe. That is A, B, C, D, E, F. At the time will not have a problem. It's not, it doesn't matter. So here the area of, or area of the given figure, because I'm taking this clockwise, that's why I'll just multiply by negative 1 over 2 times. So all x coordinates, here we have negative 2, and here we have 1, here we have 2, here we have 0, negative 3, and negative 4, and the first coordinate, negative 2. And corresponding y coordinates, that is 6, 5, 1, 6, 5, 1, 6, 5, 1, negative 1, negative 1, 2. Negative 1, negative 1, 2. The first coordinate is 6. Okay, that's equal to negative 1 over 2. Here we have negative 2 times 5, negative 10. 1 times 1 plus 1. 2 times, okay. 2 times negative 1, negative 2. 0 times minus 1 plus 0. Negative 3 times 2 minus 6. Negative 4 times 6 minus 24. That's it. Minus 1 times 6. It is 6. 2 times 5 plus 10. 0 times 1. 0. Negative 3 times negative 1 plus 3. Negative 4 times negative 1 plus 4. Negative 2 times 2, negative 4. That is the area of this polygon. Minus 1 over 2. If you simplify, negative 10 plus 1, negative 9, negative 11, negative 17, and negative 24, that is negative 41. Minus 16, 19, it is 0, so that's equal to 19. So as I say, because actually we took this clockwise, that's why it is negative here. Negative 41, negative 19, minus 1 over 2 times negative 60, which is equal to 30 units squared. So the area of this polygon or this rectilinear figure is 30 units squared. Okay?
Mm-hmm.
Okay, let's see one more example about this thing and we will finish the class. Not we will see. If we have time, we'll continue. Otherwise, can you read the problem, Amira?
In the diagram, PQRST is a straight line cutting the x-axis at Q and the y-axis at R. The coordinates of PT and M are negative 10, negative 4, 14, 2, and 4, 11, respectively, where MS is the perpendicular from M to PT. Find A, the equations of PQ and MS, B, the coordinates of QR and S, and C, the area of the triangle PMS.
Okay. That is how questions are asked in the exams, actually. So, let's do it step by step. Do we have enough space? No. So, let me just add one more slide. So that's okay. All right, we got, actually, hopefully understood the question. Everything is given in the figure. So we are talking about this line that is PQRST. That's a straight line. Coordinates of P is given negative 10 and negative 4. And also coordinates of M, it is 4, 11 and T 14, 12. All right. Okay, question 8. The equations of PQ and MS. All right, so actually write this equation, right? PQ, where is PQ? PQ, where is PQ? Okay, PQ. That equation of PQ means the equation of PT, right? So question A, equation of PQ. What is it? I just take these 2 points, right? So that is y plus 4, because y minus 4 is plus, over x plus 10. That's equal to 12 minus 4, that is 12 minus 4, over 14 minus 10. 14 minus 10. Now from here we can get the equation y plus 4 equals, it is 16 over 24 by 8, it is 2 over 3 x plus 10. Or that is 3y plus 12 equals 2x plus 20. So 2x minus 3y equals or plus 8 is equal to 0. That is the first part actually. That's the equation of, say, PQ or PR or PS or PT, since all points are on the same straight line. That actually serves for all these points. Okay, that's done. That's the first part. And how about the second part? How do you find the equation of the second part? We need to find the equation of MS, right? Actually, I think we need to write this maybe in gradient form. It will be much better. Anyway, it doesn't matter. So let me just write one more here. Y is equal to 2 over 3x plus 8 over 3. Right? That's the equation of this. How do you write the equation of MS, Amina? It's actually it's going through the point M. Okay, we know the coordinates of M. And also you can find the, what is it, gradient of MS, since MS is perpendicular to
perpendicular, yeah.
Good. That means that gradient of MS times gradient of, what is it, PT, it should be equal to -1. And MS, I don't know. So from here, gradient of MS equals -1 over, what's the gradient of PT? From here, it is equal to 2 over 3. So that is 2 over 3. So that's equal to -3 over 2. So that's the gradient of MS. Now I can, let me just write here, or, okay, like in, or MS -3 over 2. So gradient of MS equals -2 over 3, 3 over 2, 3 over 2. And it is passing through this point, 4, 11. Then equation of MS would be y minus 11 over x minus 4. That's equal to, on the right hand side, it is gradient. Or that's equal to 2y minus 22 equals minus 3x plus 12. Or 2y equals minus 3x plus 34 dot 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 y is equal to minus 3 over 2 x plus 17. That is the equation of MS. Let's see here, minus 3 over 2, and this one is 2 over 3 because they are perpendicular. Okay, we got it. Next question is the coordinates of QRS. That is B, coordinates of QRS. I think it's not so hard since we know the equation of PT, right? What is the equation of PT? Number one is, okay, 2 over 3x over 8 over 3. So let me just write here, y is equal to 2 over 3x plus 8 over 3, 8 over 3. Okay, 8 over 3. And the equation of this line, it is y equals minus 3 over 2x plus 17. Let's just do this one by one. So Q, since it is on the x-axis, right, it is y coordinate is equal to 0. So if you just substitute into this equation, we will have here, what is it? Number one, Q. So that will be y coordinate is equal to 0. So that is 0 plus 2 over 3x plus 8 over 3. So from here, what is x? X equals minus 4. So coordinates of Q are -4, 0. Dots, dots, dots. Done. R, is R on the y-axis?
Yes.
Yes, it says y-axis at Q. Okay, then it's good. So that means that for R, is coordinated something like this, right? Sorry, 0, y sub 0. Because it's on the y-axis, its x-coordinate is equal to 0. And also it is on the line PT, so if you substitute here, we will have y sub 0 equals 2 over 3 times 0 plus 8 over 3. Actually, from here we can see that because just it's y-intercept. Dot, dot, dot. Therefore, coordinates of r is 0, 8 over 3. Okay, done. And the third one is S. Okay, let's say coordinates of S is A and B. Actually, we saw similar, we already did similar example, right? Since this S belongs to the line PT and also MS, that means that if we substitute into this equation and into this equation, it must satisfy both equations. So if you just write them here, the first one is B is equal to minus 3 over 2, A plus 7. At the same time, this S belongs to the point PT. So this equation is this. So that's equal to B equals 2 over 3, A plus 8 over 3. So these things are equal. So from here, minus 3 over 2A plus 17 is equal to 2 over 3A plus 8 over 3. Let's take that to the left-hand side and this one to the right-hand side. Here we have minus 3 over 2 minus 2 over 3. And here we have A equals 8 over 3 minus 17. So what is A? A equals 8 over 3 minus 17 over minus 3 over 2 minus 2 over 3, which is equal to let's evaluate this quickly with the calculator. So it is 8 over 3 minus 17 over minus 3 over 2 minus 2 over 3, which is equal to 86 over 13. Really? Not beautiful number, but fine. 86 over 13, if you didn't make any technical mistake. So in this way, we can find the value of B. What is the value of B? That is minus 3 over 2, over 2 times A times 86 over 13, and here plus 17. 92 over 13. So from here, B equals 92 over 13. So coordinates of S is 86 over 13 and 92 over 13. Okay. In real life, in applications, you will see that the equations and numbers, they are not so beautiful numbers.
Yeah.
I mean, beautiful numbers means that's easy numbers. Maybe like not 7 or something. So anyway, and the last question is the area of PMS. Let's find this and we'll finish the class. PMS, I think, okay. We need one more space. All right. C, area of PMS. Where is PMS? Okay, PMS. I see. Okay, we know the coordinates of P. We know that's right. Negative 10, negative 4. And M, it is 4, 11. How about S, Amira? Do you remember coordinates of S?
No.
It is 86, 13, I think. And 92 over 13. Yeah, I guess, let's make sure. 86 over 13, 92 over 13. minus 3 over 2a plus 17. Okay, 2 over 3a plus 8 over 3. They are equal. Minus 3 over 2. Okay, 17 minus 17. All right, 6, 2. Interesting. Okay, I will check this later. Assuming this is correct. And we need to find the area. One way is we can find the distance between PS and it's a right angled triangle. But how about using that formula P? Okay, PMS. So that's equal to 1 over 2. Here we have minus 10 clockwise. It is, if I start from here, P S M. Okay, P minus 10 S 86 over 13. And here we have 4. Here we have minus 10. And here we have minus 4, 92 over 13. And here we have 11. And here we have minus 4. Okay, and we can just evaluate and get the answer. And I will leave this for you as a homework. I mean, let's stop here. Okay. Also, I will check one more time. And if you made a mistake with this number, 86 over 13, 92 over 13, they look a bit not nice to us. Even if it's like this, no problem. Using a calculator, we know how to evaluate this. You can evaluate this. So Amir, as I told you, now I will send you one test, okay? Whenever you have time, maybe today or tomorrow or Sunday, but you should do this until Monday. After I receive this, I will just go with this. I will send you another test for the next week, either on Tuesday or Wednesday. And next Friday, we will discuss this test 1 and test 2, and we will continue our classes, okay?
Okay. You know how you record the lessons and stuff? Remember when you sent me on like the recordings from YouTube unlisted?
Okay.
Could you do that with like all the other lessons, please?
Yeah, sometimes I forget, like for example, today the first session, I forgot to record it, but the second one I recorded. And all recorded classes, actually I was uploading in YouTube, but uploading YouTube, it took a lot of time because I'm teaching right now like you know, I have 5 students and uploading their videos and waiting every time.
Oh,
So
yeah, you have a
I change
point.
my mind. What I'm doing here is, Amira, I'm actually recording and saving all these files and everything that I share with you. And I open one folder in my drive, Google Drive, all videos are there. So I will send you the link, okay? You can reach all past classes and solve the examples and everything through this link. I think it's easy. And also you can play the video because in Zoom, the size is not so big, you can play it, okay? You just check this, all right? If there's any problem, let me know.
Okay.
Okay?
No problem. Yeah.
Okay, then see you on Sunday, Amira.
Goodbye.
Okay, bye-bye.